I hope by now you have a good understanding of double-dimensional arrays. In case you haven't watched the previous videos of double-dimensional arrays, please watch them before continuing with this lesson. Otherwise, you will not be able to understand this lesson properly. In this lesson, we will learn about three things. First is computing the sum of all elements of the 2D array. Second is computing the row-wise sum of the 2D array. And third is computing the column-wise sum of the 2D array. First, we will understand the meaning of row-wise and column-wise sum for a double-dimensional array, and then we will write a program for it. Let's again take our 3x2 2D array ARR, which we used in the previous lessons. Sum of all the elements of the array is straightforward. You add up all the elements of the array and you will get the sum of all the elements. Row-wise sum of the array means computing the sum of each row of the array. Adding 1 and 3 gives the sum of the first row as 4. Adding 5 and 7 gives the sum of second row as 12. Adding 9 and 11 gives the sum of third row as 20. So this is how we compute row-wise sum. For column-wise sum, we compute the sum of each column of the array. Summing up the first column gives 15 and second column gives 21. Okay, I hope now you are clear about calculating row-wise and column-wise sum and the sum of all elements of the double-dimensional array. Let's switch to BlueJ and see the program for it. This is the program to calculate row-wise, column-wise and sum of all elements of the double-dimensional array. Here we accept the array details from the user. After that, we display the array in matrix form. Then we compute the row-wise sum and sum of all elements. Finally, we compute the column-wise sum. That's a quick overview of the program. Don't worry, I will explain you this program in detail like always. But first, let's execute it and get the output so that it is easier to understand the program. I will enter the same array that we used in the example earlier. 3 rows, 2 columns. Elements of the array are 1, 3, 5, 7, 9 and 11. This is the array displayed in matrix form. Then we have the sum of each row followed by the sum of each column, and finally the sum of all elements is displayed. Let's shift to the program now. This part of the program should be familiar to you. We discussed it in the earlier lessons of double-dimensional array. Here we ask the user to enter how many rows and columns he wants for the array. After that, we ask him to enter the numbers and store them row-wise in the double-dimensional array ARR. Here we display the array in matrix form. I am doing this so that we can easily cross-check in the output if the sum values are computed correctly or not. If you are writing this program for your exams, then you can skip this part if the question does not explicitly mention about displaying the array in matrix form. Okay, now we will go to the main part of the program. Let's see how this part of the program is computing the row-wise sum and sum of all elements. First, we declare an int variable sum and initialize it to 0. This will hold the sum of all elements of the array. Next, we have this outer loop for the rows of the array and inner loop for the columns. With the help of these two loops, we traverse the array row-wise and add each element of the array to the int variable sum. To compute the sum of each row, we declare this int variable rsum just before the inner loop starts and initialize it to 0. Inside the inner loop, we add the elements of the row to rsum. Once the inner loop completes executing, we have sum of the row in rsum. We then print it outside the loop. Still having confusions in how the sum of each row is getting computed? No worries. Let's do a dry run of this part. It will make things clear. Let's start from here. Sum is initialized to 0. After that, outer for loop begins and I is initialized to 0. Next, rsum is initialized to 0. Program control comes to the inner loop after this and j is initialized to 0. Program control enters the inner loop and comes to this statement. Both I and j are 0, so ARR of 0, 0, which is this element 1, gets added to sum. Sum becomes 1. In the next statement, the same element ARR of 0, 0 is added to rsum, so it also becomes 1. Next iteration of for loop begins. J becomes 1, I is still 0, ARR of 0, 1, which is this element 3, gets added to sum and rsum. Both become 4. Program control again comes back here. J becomes 2. Now the condition of this loop is false as j is no longer less than columns. Program control comes here and prints the sum of first row to the console. So, you saw how one complete execution of the inner loop gives us the sum of one row. After this, the next iteration of outer loop starts. I becomes 1. We reset rsum to 0 as now we want to compute the sum of next row in rsum. J starts from 0 again. ARR of 1, 0 is added to both sum and rsum. Sum becomes 9 and rsum becomes 5. Next, j becomes 1. ARR of 1, 1 is added to both sum and rsum. Sum becomes 16 and rsum becomes 7. Now j becomes 2, so condition is false. Sum of second row is printed to the console. Till this point, we have computed the sum of all these elements in the variable sum and printed the sum of first two rows. In a similar way, the sum of this last row is computed. 9 and 11 also get added to sum, giving us the sum of all elements of the array. I hope now row-wise sum is clear to you. Let's move to column-wise sum. Column-wise sum is like row-wise sum, just that now we need to traverse the 2D array column-wise rather than row-wise. To do this, we will again use two loops, but the outer loop will run for the number of columns and the inner loop will run for the number of rows. Note that this is opposite to row-wise sum. In row-wise sum, outer loop was running for number of rows and inner loop was running for number of columns. Now we need to go over the array column-wise, so outer loop will run for number of columns and inner loop will run for number of rows. Let's do a dry run of this part and see how it is working. Starting from the outer loop, I is initialized to 0. Then we initialize an int variable csum to 0. This is like the rsum variable we saw earlier. It will accumulate the sum of each column. After this, program control comes to the inner loop. J is initialized to 0. Next, program control comes to this statement. Note that here the first subscript of ARR is j and second is I, unlike row-wise case where I was first and j was second. Both j and I are 0, so this first element 1 is added to csum. Next, j becomes 1. Now ARR of 1, 0 is added to csum, making it 6. Notice that how we move to the second row of first column by using the loops and subscripts in this way. This is column-wise traversal of double-dimensional array. Next, j becomes 2. ARR of 2, 0 is added to csum, making it 15. After this, j becomes 3. We gave the number of rows for our array as 3, so the variable rows has a value of 3. As j is no longer less than rows, so condition of inner loop becomes false. Program control comes here and prints the sum of first column to the console. Similarly, the sum of second column is also computed and printed to the console. Finally, this statement prints the sum of all the elements of the array which we computed earlier, and with this our program completes. Let's run this program one more time with a different array. This time I will input a 3 by 3 array. Let me input the elements now. So our program can compute the row-wise and column-wise sum and sum of all elements of all double-dimensional int arrays. With that, let's wrap up this video. Goodbye.